Hi, on behalf of 24-Hour Answers team, I would like to welcome you to today's lesson. Today's lesson is electric force, or better yet, Coulomb's law. As we have mentioned in our previous lessons, every electric charge creates an electric field around it. That field is a region within which the charge can exert its electrostatic influence. Electrostatic influence, or electric force, is described by the Coulomb's law. It explains how two or more electric charges influence each other. Take a look at the picture on your screen. Two electric charges of the same sign repel each other, which means they are either both positive or negative. On the other hand, two electric charges of the opposite sign attract each other, which means they are either positive and negative or negative and positive. At this point, we know in which cases charges attract or repel each other, but we still do not know the magnitude of that force. If you remember, we measured the strength of the electric field by introducing a positive test charge, small q, which is infinitesimally small, so it doesn't change the configuration of the field that we are trying to measure. Afterwards, we said that that positive test charge will then experience a force, and the ratio of the force to the charge is the electric field. You can see that on your screen. We can write this a little bit differently and get that the force equals to electric field times the charge itself, and that is the Coulomb's law. You can see that on the bottom of your screen. To summarize, the magnitude of an electric force can be calculated with the formula below. If you're wondering why we use the absolute value, the answer is, well, we just want the value of the force itself. We don't need the sign, because the sign just gives us the direction of the force, and we usually figure that out up front before we get to the formula itself. You should know the rest. Basically, what do we have in the formula? We have Q1, which is the first charge. We have then the Q2, which is the second charge. Epsilon 0 is the permittivity of free space, and you can see the approximate value on your screen. Epsilon r is the relative permittivity of the material in which the charges are immersed. And of course, r is the distance between two charges. We can also write the formula in another way, using the Coulomb's constant. You can see that on your screen, and there's also the approximate value of the Coulomb's constant. Unit of electric force is Newton. As you have seen, two electric charges exert forces of equal magnitude on one another, but in opposite directions. There is one important note. There is no such thing as a formula for multiple charges, or basically more than two. If we have more than two charges, we have to calculate the force for each combination and then add them as vectors to be able to get the total force on a certain charge. That should be it. Thank you for your time. Check out our YouTube channel for more lessons.